Let's talk about calculating our short circuit current rating, or SCCR, or interrupt rating of our control panel. Now, if you are building a UL508A industrial control panel, or honestly, if you are building one and it's not UL, then it should have an SCCR rating on the outside of the panel. Now, our SCCR rating is different than our current rating on our power devices. This Siemens 3VA6 circuit breaker is rated for 40 amps of current, but it has an interrupt rating of 100 kiloamps. And what that is defining is how much current this device can handle for a set amount of time. And mainly that's the time it takes to break the circuit. So in this case, it can handle 100 kiloamps worth of current in the time it takes to clear its faults. Now let's talk about what SCCR is not, and I see a lot of you folks do. As a lot of you take your main breaker and say, oh, well, this is 100 kiloamp. That means the panel is 100 kiloamp. No, that's not how it works. We're going to find the weakest link in our system to find the overall interrupt rating. Now next, let's talk about how thinking about this on the front end can increase the interrupt rating of our panel instead of us doing an afterthought. Because I'm going to show you how we're going to take this panel from a 10 kiloamp rating to a 100 kiloamp rating. Now, we all love circuit breakers because they're easily reset when we have a problem. And yeah, fuses, we have to change the fuses, but here's a good example of how a fuse can increase the interrupt rating of your control panel. This is a molded case circuit breaker. This is a good high quality device. And yeah, at 240 volt, it has an interrupt rating of 100 kiloamps. But when we scale it down to these miniature circuit breakers, they typically have an interrupt rating around 10 kiloamps. And similarly, a lot of us put distribution blocks into our control panels to give us a convenient spot to connect multiple wires. An unlisted one is going to be rated for 10 kiloamp. If we get a listed one, then it's going to be rated, in this case, for either 100 or 200 kiloamp, depending on the wire that you're using and the ampacity. And in our final example, if we have multiple circuit breakers, or in this case, fuses, this is a really convenient option to connect these. But unfortunately, if I look at the side of this device, it says the SCCR rating is 10 kiloamp. So simply by leaving a few of these devices out or swapping out a few part numbers, we can really increase the kiloamp rating. So let's talk through how we would do the kiloamp rating with what my initial thought was of how I'm going to wire this panel, and how changing certain products out increase the kiloamp rating. And we are going to use UL508A's SB1 supplemental to do our calculation. And really, it's a three-step process to do this. First, we're going to determine the short circuit current rating of all of our individual power devices. And you can find a list of what power devices are in SB421. And it says all power components, including disconnect switches, branch circuit protected devices, branch circuit fuse holders, load controllers, motor overload relays, terminal blocks, bus bars, and line filters such as electromagnetic interference, or EMIs, radio frequency interference, or RFI filters, or active or passive harmonic filters shall have a short circuit current rating or interrupting rating expressed in amperes or kiloamperes and the voltage. Now, there are several exceptions below that, and you can find that list in the SB supplemental. So we're going to start with our main breaker, and it has an interrupt rating of 100 kiloamps. But again, just because you have a main breaker of 100 kiloamp doesn't mean that your panel is, because we have to consider everything else. My initial thought was to use circuit breakers here, and the ones that I was going to use was 10 kiloamp. Now let's talk about devices that we can't find the interrupt rating for. UL does have a very convenient table that you can go to, but let's talk about the pitfall of using UL's table. If we look at table SB 4.1, this is the assumed maximum short circuit current rating for unmarked devices. If we look at circuit breakers, including GFCI type, then the short circuit current rating of them would be 5 kiloamps. So just by looking at the side of the breaker that I was going to use, I got us to 10 kiloamp. But also that includes this too. If you do not use what's on it, we're going to make an assumption that this is 5 kiloamps. This actually is 100 kiloamp. And we're going to do the same 10 kiloamp here, 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 and here. So by switching to this fuse holder and our class CC fuses, both of those have an interrupt rating of 100 kiloamp. That gets us to 100 kiloamp rating on our fuse blocks. But we have this really convenient bus bar going across here. And unfortunately, that is still 10 kiloamp. So even though we're 100 kiloamp here and we're 100 kiloamp on all of our fuses and fuse holders, our panel rating will still be 10 kiloamp. And I know it's going to break a lot of your hearts the way that I'm going to solve this, but yeah, we are going to use jumper wires between each of our fuse holders, because this does not have to go into account when we're doing our short circuit current rating. Now we have a few more power components to consider. We have a transformer here and we have a power supply here. And that falls under exception 1. Power transformers, reactors, current transformers, dry type capacitors, resistors, 1-port SPDs, power monitoring devices, and voltmeters are not required to have a short circuit current rating. So you would continue this through the rest of your power devices. And for figuring out a basic short circuit current rating, you will just go through all those devices and find the lowest number, and that'll be the short circuit current rating of your panel. Now, there are 2 other items to take into account when you're figuring this out. We have combinations devices, and the most often one I see is our motor starters, where we have a manual motor starter. We probably have a short jumper, and we have a contactor, and the manufacturer may get an overall rating for it that's higher than some of the individual devices. And then we have current limiting breakers, and that is a really interesting one. And if you'd like to learn more about those, then put it down in the comments and maybe I'll do a video on it. But we can take a current limiting breaker a lot of times, and maybe our overall short circuit current rating would have been 20 kiloamps, and we may be able to raise it up to 50 kiloamps. So take the time and think about that beforehand. And then let's talk about how we're going to do our control panel wiring. And click here to follow me over there.